Okay, now we'll be starting with the laws of set theory. So basically, we have various laws which are used to solve various sets of problems in set theory. Okay, uh, there are around 8 laws. One of the famous law is De Morgan's law. Okay, it's quite famous and it goes by the name. Okay, so what are the 8 laws? Now, the first law, like I think the first 3 laws we have already studied in uh, primary classes. At least you know the names. The first is commutative law. Okay. So, what does the commutative law actually says? Remember one thing: the laws will go for union operation as well as for intersection operation. Okay. For commutative law, the operation will be A union B is equal to B union A, and similarly A intersection B is equals to what? B intersection A. Okay. Okay. So this was the commutative law. Now, commutative law क्या था कि A union B is equal to B union A, and it goes the same for intersection operation. Next is associative law. Associative law में you just change the uh, pairs. Okay. जैसे कि इसमें you took A union B union C, and B union C was taken as a pair, which is equals to A union B union C, and this time A union B was taken as a pair. Similarly, it's the same case for intersection operation. Next, you have distributive law, which says that A intersection B union C. So now this thing will be multiplied inside. Okay, so this will become A intersection B union A intersection C, and this is the same case as above, just changing the operations, order of the operations. Next is complement. I've written the spelling wrong. This is complement. Okay. Complement law. Complement law says that A union A complement is the universal set. I hope you remember this thing, that this suppose this is a universal set. This is a universal set, and this is a any any set, fine, any set A. So this is A, and then this is what? A complement, right? So when you will take this plus A complement, this will give you the universal set, right? Because this is the whole is the universal set. Similarly, if we are trying to find the intersection between A and A complement, so this will be 5 because we don't have any common elements between the two sets. Next is the identity law. Identity law states that A union phi is A, and this is equals to phi union A. Similarly, A intersection universal set is A, and vice versa. We have absorption law. Okay. Then we have the De Morgan's law. De Morgan this law is very famous. It states that the complement of A union B is equals to the intersection of the individual complements of both the sets. Similar is the case for the intersection operation, that the intersection of the complement of the intersection of set A and B is equals to the union of the complements of the respective sets A and B. And last we have the involution law, which says that if you complement a already complemented set, then it will give you the set itself. Now last we have the famous principle, which is the principle of inclusion. Now the principle of inclusion states that if you have two sets A and B with the cardinalities as mod A and mod B, okay, then the equation will be okay. So okay, so the principle of inclusion is this for two sets A and B. Okay, it states that the A union B is equals to set of A plus set B minus intersection of both the sets. The same formula can be extended to a group of three sets A, B and C, and this is this. Okay, now there are some certain problems. Okay, now the first question is, now consider a survey conducted on 250 persons, and it was found that 180 drink tea and 70 drink coffee, and there are 50 people who drink both tea and coffee. Our question is, how many drink at least one beverage and how many drink neither? So there are two parts to this question. The first part is how many drink at least one beverage. Now whenever the questions are asked in such a format that how many drink at least one beverage, or like if it is said that at least one, then you have to find union. Okay, so the formula will be directly applied, A union B, and let us consider the set A, let us consider set A to be the set of tea drinkers and B to be the set of coffee drinkers. Okay, so this will be A plus B minus A intersection B, which is A is 180 plus 70 minus 50, and the answer is 200. So there are 200 persons who drink at least one beverage. Now the next part of the question was that how many drink neither. So I told you already that the total persons available were 250, and you found out that at least one beverage drinkers are 200. So we are going to subtract both 250 minus 200, and that is 50. So there are 50 persons who drink neither tea and neither coffee. Okay, next question is, how many integers between 1 and 468 are divisible by 3 but not by 5? Now to find this, you have to start like this, that number of integers between 1 and 468 which are divisible by 3. So number of integers which are divisible by 3 will be 468 divided by 3, which is 156. Now second will be number of integers between 1 and 468 which are divisible by 3 and 5. So 468 divided by 3 into 5, and that will give you 31. Okay, now last will be that number of integers between 1 and 468 which are divisible by 3 but not by 5, and for this you are going to subtract both. So 156 minus 31 will be 125. This is like set difference, right? Number of elements which are present in A but not in B. So that this is the reason we subtracted it. Now, how many integers, next question, how many integers are between 1 and 200 which are divisible by any one of the integers 2, 3 and 5? Again, this is a similar pattern which I told you, that they have said that in the question that you have to find the integer which are divisible by any one of the integers. This means that you have to find what? Union. The only catch in this question is that instead of having two sets, you are having three sets. Okay, so you are going to directly apply the formula, but before applying the formula, you have to find the value, right? So now let us consider a1 to be the set divisible by 2, a2 to be the set of integers which are divisible by 3, and a3 to consist of the set of integers which are divisible by 5. Okay, so now a1 is 200 by 2, this is 100. a2 is 200 by 3, which is 66. a3 is 200 by 5, which is 40. Now a1 intersection a2 is 200 divided by 2 into 3. Why? Because a1 and a2 is 2 and 3. This is 33. a1 intersection a3 is 200 upon 2 into 5. This is 20. And a2 intersection a3 is 200 divided by 3 into 5, which is 13. And finally we have a1 intersection a2 intersection 3, which is 200 divided by 2 into 3 into 5, which is 6. Finally you are going to put all the values in the formula. So this is a1 plus a2 plus a3 minus a1 intersection a2 minus a2 intersection a3 minus a3 intersection a1 plus a1 intersection a2 intersection a3. So finally our answer will be 146. Okay, so 146 are the integers which are divisible by any one of the integers 2, 3 or 5. Okay.